We recently talked about these binomial settings, and the way we're going to check to see if it's a binomial distribution is we're always going to use our bins. Um, so if you look at the first one, genetics says that a child receives genes from each parent independently. All right, right away, the problem says independently. So I'm going to go ahead and check that off. And it says 0.25 of having type O blood, and then 0.75 of not having type O blood. Suppose that these parents have 5 children. Let X equal the number of children with type O blood. So is this a success or failure problem? Yeah, our success is type O. Our failure, not type O. Is it independent? It is indeed independent. Knowing one children's blood is not going to tell us anything about the next person's blood. So therefore it is indeed independent. Does this have a fixed number of trials? Yep, we say 5 kids. And then finally it says, what's the success here? And well, the success of type O, as they tell you, it's 0.25 of having type O blood. So this actually meets every single requirement. So A is indeed binomial distribution. B, shuffle a deck of cards, turn over the first 10 cards one at a time. Let Y equal the number of aces you observe. So success is an ace, failure is not an ace. Is it independent? This is not independent. And the reason why that is because if you turn over the first card, that's a 4 out of 52, and if that's an ace, you no longer have 4 aces. You now have 3. So what happens is the probability changes. So like, the first card's an ace, the next card is less likely to be an ace because we're not replacing in here. And it could really go the other way, is if the first 5 cards are not aces, as you go along you're more likely to get an ace. So these are actually not independent, so therefore this is not going to be a binomial. But I mean, you could just check the rest of it. You do have a fixed number of trials, it's 10. The probability you get an ace is 4 over 52. But because it does not solve the independent, this one is not a binomial distribution. C says shuffle the deck of cards, turn the top card over, put the card back in the deck, and shuffle again. Repeat the process until you get an ace. Let W equal the number of cards required. So success is an ace. Failure is not an ace. Is it independent? Since we are replacing the card and shuffling the deck each time, one trial doesn't tell us anything about the next, is because we have replacement and we shuffle. So therefore, so far we're good on the first 2 things. And then, well, we know the success is 4 over 52. And then the last thing, it says the number of trials. Well, this just says let W equal the number of cards required. So it's not set in advance. So we could get like an ace on the first try and be done with it. Or it could take us 20 or 30 tries. But it fails having a fixed number of trials. We don't know how many it's going to take. So therefore, this is not a binomial distribution.